Hi everyone, in this video we'll be continuing on with the SageMaker Inference playlist series, and this is a direct follow-up to the load testing SageMaker endpoints. I'll link that beneath in the description, but as you can see in the agenda right there, what we'll talk about is what's really next after load testing, which is autoscaling in this case in terms of what we'll be covering. And then we'll also talk about how do we exactly scale, right? What are the different supported CloudWatch metrics that are kind of enabled for SageMaker? How can we use them to really define a robust autoscaling policy that will really help you productionize your ML model that you have deployed on the service? And then we'll get hands-on in terms of enabling autoscaling for SageMaker endpoints itself. So this will be the same scikit-learn model that we've already deployed. So go up a little earlier in the playlist if you want to understand the exact nuances behind deployment itself. But we'll talk about enabling autoscaling for that specific model that we worked with. With that being said, let me connect the whiteboard directly like always. We'll just spend a few minutes kind of going over what exactly I mean by autoscaling, how does it work within SageMaker, and then we'll get hands-on as always. And here, right, just a quick refresher, what we were working with before was load testing these SageMaker endpoints. And if you remember, during load testing, there were two real metrics that we were tracking. Throughput, which can be known as transactions per second or requests per second, that's what we were really looking at, and latency. And what we were trying to do is, via our load tests, we want to find the optimal hardware configuration behind our endpoints, so the instance types or things of that sort, the optimal one of this optimal hardware configuration that helps us meet our requirements for these two buckets, and we sometimes call them like SLAs. And with load testing, what we really did was we took a single instance behind our endpoint, and what we tried to understand was, with that single instance, how much juice could we really squeeze out from these two buckets in terms of achieving our goals. And let's say, for instance, right, I have a C5x large, and I know that I can achieve about 100 transactions per second while saturating my hardware, or let's say CPU utilization, at 80%. And let's say our peak TPS that we're trying to achieve, right? This is maybe our peak or maximum. Based off our load test, we could probably extrapolate that it might take about 10 of these instances to reach up to 1,000 transactions per second. So the real idea behind our load testing was finding that kind of combination in terms of here's my peak traffic that I might need to achieve, but with a single instance, let's see what the maximum I can derive or get out of this instance is. And that will help us understand, while also taking a look at how it impacts our hardware utilization, what's the right combination of maybe hardware that I need behind my endpoint itself to be able to achieve the performance metrics that I need. And that's where autoscaling is introduced, right? And specifically within scaling, there's two types of scaling that I wanted to cover, but today we'll be talking specifically of one. There's vertical and horizontal. Within vertical scaling, right, you can increase the compute power of the instance itself. And what I mean by this is, let's say, returning to that same example, we have a C5x large, and this has maybe, and these are probably the wrong numbers, I don't remember the exact count. It has maybe two CPU cores. And I say I actually want a beefier instance, such as maybe a C5 16x large, which has something like 32 cores, right? This actually increases the compute power itself behind the instance. So I have a larger set of compute, maybe the same instance count, but my machine itself is more powerful and able to handle more traffic and perhaps handle a higher throughput at a better latency than my previous instance was. So that's one way of scaling. The way of scaling we're going to talk about today, or where we'll apply our autoscaling policy, is known as horizontal. Let's say I stick with my C5x large instance, and I start with just one of these behind my endpoint. And let's say I apply my autoscaling policy then. What happens is we can vertically scale this out. So rather than just having one instance, we're going to have multiple instances behind the endpoint. But this is really only effective if you have a robust scaling policy that reacts well and properly to your traffic. And it makes sense intuitively based off your load tests. And this is where load testing will be useful, right? Because if you remember, there's a few metrics, CloudWatch metrics, and CloudWatch, for those of you that are new, is kind of the AWS service for metric and kind of log tracking for many different services, including SageMaker. There's a few different CloudWatch metrics that we can use to really define the scaling policy that we tracked during our load tests in the previous video. There's instance level metrics, and then there's invocation level metrics. And we'll cover all of this again in the hands-on as well. In terms of the instance level metrics, this is things such as CPU and GPU utilization. And this is essentially us seeing how saturated is our hardware, how much traffic, at what traffic rate is our instance really getting consumed. Because at one point, your instance is not going to be able to handle more traffic than a certain rate that you might be passing in. So we really want to track this. We talked about how 80% saturation is often like a sweet spot on which we at least scale on, or kind of a rule of thumb that I use. And then there's also invocation level metrics. So this is invocations per instance that you might be working with. Completely butchered the spelling there as always. But here there's going to be invocations per instance. There's other metrics such as model latency, overhead latency, and things of that sort, right? So this is more specifically within the container, how many requests we're processing. And really the beautiful part about the load testing is, right, we managed to find the right combination of these metrics that help us define a robust scaling policy. So let's say I know that at 100 transactions per second, I'm at 80% CPU utilization based off my load tests when I have a C5.x large instance behind this. And let's say I know that at my peak, I need to hit 1,000 transactions per second. We can tell our scaling policy, hey, when we're at 100 transactions per second, ensure that you scale out, because I know that my hardware is going to be really, really saturated and start being unable to handle any further traffic. Or you could even define it based off the CPU utilization itself. You can say if my hardware ever reaches 80%, then scale out, because I know that my instance is getting saturated. So you can pick whichever metric you're comfortable with. But the key is you want to load test no matter what to really understand the combination of both of these different sets of metrics to really define that robust scaling policy. For today's hands-on, we'll go over the invocations per instance specifically as kind of our target metric. But what we'll do is we'll get hands-on right now as always, and we'll try to walk through and explain all these different kind of features and metrics that I'm talking about. So no worries if you don't understand it fully. We'll cover it in this lecture itself too. So if we go into our console, I'm in SageMaker AI as always. You can run this in Studio. We are using a classic notebook instance here itself, but you can use whatever environment you're comfortable with. Unlike our load testing video, we're not generating any traffic, so you can even run this locally as long as you're authorized or authenticated to work with SageMaker. But if we get in here, I've cloned that same Git repo where we have all these different inference video series and scripts, so I'll attach that in the description as well. But if we get here to the AutoScaling notebook, you'll notice I have the same model artifacts, the same scikit-learn model that we've been working with for deployment. Please go to part 1 of this series to understand more about the nuances of deployment itself. But if we see here, we have the same kind of tools that we've been using, the higher level SageMaker Python SDK, the Boto 3 AWS Python SDK, and this is especially crucial because this will let us work with any AWS service. We're going to have to use a few others here. But here I set up everything. I set up my different clients to work with SageMaker. I create that model tarball with our model data and artifacts. And then in this step, I create our persistent SageMaker endpoint. And as you can see, you can invoke it using that API call, this invoke endpoint API call. Everything in SageMaker real-time inference is really derived off this invoke endpoint API call, all the metrics and everything. So this is our point of contact as we talked about before. Now the next step, right, specifically for this video is enabling autoscaling for our SageMaker endpoint. So SageMaker real-time endpoints are integrated with something known as application autoscaling. And what application autoscaling is it's a service within AWS where you can horizontally scale different AWS resources. And this includes obviously SageMaker endpoint variants and inference components that we'll talk about later. But this applies across different AWS services, and it essentially enables you to say, here is the resource I want to scale on. Here's the supported CloudWatch metric. That's the target metric that will trigger my autoscaling. So to talk with this, we use our old friend Boto 3 to pretty much instantiate a client there. This is our autoscaling client, and what we have to do now is set up a few different parameters. First, we need to enable the resource ID for application autoscaling to pick up on. And you can see here the supported SageMaker AI endpoint variants in the documentation. What we do is we say, hey, this is the resource identifier. Here's my SageMaker endpoint name that I've defined earlier. Variant name, for those of you that are confused or not aware of that, here in the endpoint configuration, if you remember, we have a tab known as production variants. It might seem a little useless here because there's only one variant, but when it comes to shadow testing or kind of A/B testing, where you might have multiple variants you're working with, this is where it becomes useful. But essentially, we pass that in, and in this string, this is essentially our resource identifier. What we then say is, at the minimum, we want a single instance. At the maximum, we want two instances. We're setting up those variables ahead of time. Real-time inference, just so you're aware, there's also a feature now, I believe, where you can also scale down to 0. So this could be 0, but we'll just start with 1 for the purpose of this use case. We then talk about our exact scalable target, our resource that we want to scale, which is our SageMaker endpoint. And that's why we pass in this resource ID right here, which is pointing towards our specific endpoint. We talk about the minimum and maximum instance count that we want to be able to scale for the instances behind the endpoint. Now the next part, right, is our target metric itself and the threshold for that metric. And what this means is, right, let's say invocations per instance, right, is the exact metric that we want to scale on, and that's this parameter right here. And this can be any of the CloudWatch metrics that we're talking about, right? So if I go to this inference endpoints and I see my endpoint created right here, it can be any of these different CloudWatch metrics that we have enabled here. So this includes operational/instance or any of your invocation metrics. For us specifically, we say we want to scale based off of these invocations, for instance. And the next thing you have to define, right, is the threshold. So we used 100 in the whiteboarding session. Here, I'm just setting a kind of random arbitrary number of 10 invocations per minute. The granularity for this metric is per minute. So I'm going to say if I ever hit 10 invocations consistently in a minute, that's our threshold for when we should trigger scaling out. And that scalable dimension, like we said, is that desired instance count. And we once again pass in that resource ID that we were talking about. And then two more parameters at last that we defined, right? And this is really up to you and the way you expect your application or model to be responding is scale out and scale in. So I say for scaling out, if you see 60 seconds of our threshold being breached, which is our target value right here, then scale out. Scale in after 400 seconds of not seeing our threshold value not being hit. So these are two different numbers that you can define and set up depending on your use case. Like I said, I've kind of defined all these randomly, but you really want to come to this threshold value. This is really key in a real production setting in terms of what you're seeing in your load tests. So if you know at 100 transactions per second, that's when you're really going to be saturated, then you want to set this value appropriately. Same with like your utilization metrics in terms of your instance or anything of that sort. But yeah, that's really all you do in terms of setting up autoscaling itself within SageMaker. It's once again using this Boto 3 Python SDK client, registering that resource that we're working with, and then more specifically, the exact CloudWatch metric and threshold values, and also in terms of scale in, scale out. Those are the things that we defined there. And now just to test autoscaling, we can't see this in live because I already ran it. What I did was I ran this for a certain duration, I think about 4 minutes, where we hit this endpoint repeatedly with this invoke endpoint API call, and we'll see that in our metrics in a second. And what I then do is I pull, after I run this for 4 minutes, I pulled the endpoint with the describe endpoint API call, where I was able to see the endpoint count updating essentially. And you might have to rerun this a few times because sometimes there's a bit of a cold start behind autoscaling before it gets triggered. But here we see our endpoint status goes into updating. This is when our hardware is being updated in terms of the resources we have behind it. And we can see our instance count gradually hits 2, and I kind of sleep this endpoint's updating status so you don't get like bombarded here. But you see this update eventually to 2 instances, which is the max instance count we had defined behind our endpoint. And we can see this behavior too, right? If we come to our endpoint itself, you'll see in settings number 1, I think this is scaled down because it cooled down by the time of this recording. But you can see our instance min and max is 1 to 2. And you can see here in monitoring, if we go specifically to our invocation metrics, I'm going to do in the past hour, I ran this earlier, and I do sum, you'll see that its peak, it was hitting about 3.1K per instance, and then it actually scales down or cuts into half at these data points right here within a separate moment. And the reason for this is we've now scaled to more instances where the traffic is being distributed across your scaled out kind of workload that you have. So the real key here is understanding these metrics. I can't emphasize that enough in a production setting. And in your load tests, understanding how your traffic rate is impacting these different metrics. And from that, deriving the auto scaling policy that will be able to handle your production grade traffic that you might be working with. So yeah, I think that was it at a high level itself for autoscaling SageMaker endpoints. This is one of many ways to improve performance. There's also ways you can improve latency and throughput at the container or serving layer itself, and that's something we'll approach in different videos um, in terms of the model server container that you can use. But in terms of scaling your hardware itself horizontally, it's very crucial to define this autoscaling policy, right? So that it's robust and responds to your traffic in the way that you expect. And I think that's it for what we'll be covering today, but we'll continue on with the series. We'll start exploring in the next iteration multi-model deployments and the different options that exist for that within SageMaker. So we'll review that a little in terms of what's to come. But yeah, as always, thank you for watching. If you enjoyed it and it was helpful, please feel free to leave a like and subscribe. And any questions or any doubts that you have, please reach out to me directly over LinkedIn or Twitter, and I'm more than happy to help. Thank you as always, and I'll catch you all soon.